So topic 2, a bit of some calculus. Then
Calculus.
that's where you find tangents and normal. What is your topic 2?
Financial calculus.
All right. Somebody came from first day class. So under differential calculus, the eyes are on tangents and normal lines before you can advance to the series to Taylor series, and then some general series. So if I'm given a function f, we understand that a line has to be y is equal to mx plus c, or y minus y1 is equal to m x minus x1 alternatively. So this means that if I'm given a function f, there will be need for me to find m. You know, if you're given 2 points, it's easy for us to find the m because we just get the difference between 2 points and then divide. And that gives us m. But if we don't have 2 points, we're having a function, then we'll say, okay, then m is always going to be the derivative of the function evaluated at the point given. So if I say the point is a comma b, this means that we evaluate this gradient, this derivative, for us to get the gradient. And then we should also keep in mind that since you're talking about the tangent and the normal line, that the gradients of the two are related by this equation. M tangent multiplied by M normal is actually equal to -1. So this simply means that if you give me the gradient of the tangent line, then you have given me the gradient of the normal line via this equation. Examples. If we say find the equation of the tangent and normal line to the curve x squared plus y squared is equal to 1 at the point at the point 0,1. Maybe I bend it a bit. Let me shift it a bit. At the point half to the curve when x is equal to half. Let me just do that. So find the equation of the tangent and of the normal line to the curve x squared plus y squared is equal to 1 when x is equal to half. So when does this happen? So how do we come out of the situation? Say, okay, the function given is not a standard function. This is just a curve that we understand at this level that this is a circle. And so we know that for sure when x is half, there is some output of y. So maybe the first thing would be to find the response. What do we get when x is half? So we got the function and substitute. Where there's x, we take half, square it, and then y squared, we get 1. And this means that we have a y squared is equal to 1 minus 1 over 4, giving us 3 over 4 as y squared. So y is equal to plus or minus the root of 3 over 2. Now we understand what this means, because if I have a circle, then if half is here, of course we'll have a response here, and we'll have a response there. So we expect two values. So plus or minus the root of 3. So we have 2 points then. We have half, a comma, a positive. You can use a positive and ignore the negative. It was just needed 1 point here. Now, meaning that we want to find a tangent line that is touching the graph at that point. So if that line is coming something like this, that would be a tangent line. Then a line perpendicular to the tangent that cuts, so that line could be cutting in between here. And this line is the normal. Line. This is the tangent. So we want to get this now. So saying for the normal line, we need to have, for both of them, we need to get a gradient. The first gradient will be the gradient of the tangent. So we differentiate this one now. Using power rule and implicit differentiation. So we differentiate x squared and get 2x, and then differentiate y squared and then get 2y multiplied by dy dx, which is equal to 0. Because the derivative of 1 then is 0, implying that dy dx is equal to negative 2x over 2x, over 2y, when you divide the 2y there. Then remember we said that to get m, you evaluate this derivative at the point. So we have negative x, that is negative half, over, which is the same as multiplied by y. So we reciprocate it. It becomes this, so that we get negative 2. And in the 2's there will cancel, so we just get negative 1 over the root of 3. What we have gotten here is the tangent gradient. This is for a tangent. Why is it for the tangent? If it's for a tangent, how do you use it? You have the equation. We can go for the simplest one. Y minus y1, that is root 3 over 2, is equal to m. M is negative 1 over root 3. X minus x1, that is half. You can choose to expand and leave it like that, unless some form has been asked. And then we now get the gradient for the norm. So say that is -1 over the non-gradient -1 over the root of 3. This is just equal to positive root 3. So we have y minus the 0.3 over 2 is equal to, the gradient now is root 3, x minus half. So this is how we get the tangent and the normal line equation. At a specified value of x, then you have to form a point. These points make sense in such a question. Any questions? Okay, no question. In 2, and the question is here, the tangent line to the curve y is equal to the mean the root of ax plus b at the point 5, 5 is parallel to the line 8y minus 2x is equal to 15. Find the values of a and b. B, find the equation of the norm to the curve at the point 5, 5. So the tangent line to the curve y is equal to ln that at the point 5, ln 5 is parallel to the line given. So let's find the gradient of the line 8y minus 2x is equal to 15. So we write this as y is equal to 2x plus 15 divided by 8 divided by 8, which is y is equal to x over 4 plus 15 over 8. This equation implies that the gradient m is 1 over 4. This gradient is the gradient of this line here. But the good part is that this line is parallel to the tangent line to this curve at the point 5, 5. So if it is parallel, it means that the tangent line at that point to this curve has the same gradient as the gradient of the line given. Because parallel lines share the same gradient. So parallel lines have equal gradients. So what this means actually is that if you consider squaring again, well, first we use the point. First find a and b. Let's just go for a point. If you substitute in the function, where there is x, you take 5. Where there is y, you must have ln 5. So this implies that ln 5 is equal to ln the root of ax, that is 5a plus b. Now the laws of logarithms, if I have same base, it means the inner parts are equal. So 5 will equal to the root of 5a plus b. If I square here and square here, we'll simply get 25 is equal to 5a plus b. So this is our equation 1 to deal with in the search for the values of a and b. Second thing, we're given the gradient, so differentiate the function. We'll get y prime, and then y prime, when you substitute 5, you should be able to get the gradient that is given here, 1 over 4. So we have the function written as ln ax plus b to the power half. We want to differentiate this guy. To differentiate this function, you differentiate the inner. So we get half ax plus b, subtract the 1, and then multiply by a, and then divide by the whole thing, which is the root of ax plus b. So that negative half can go down. So we're going to have half. On top, we just remain with a, and the 2 root ax plus b, another root ax plus b. This can be simplified as a over 2 ax plus b. So where there is x, when we take 5, we're going to have a situation like a over 10a plus 2b is equal to 1 over 4. When we substitute x in the derivative, it means that we are seeking to find the value a and b. If we cross multiply here, we'll surely have 4a is equal to 10a plus 2b, so that writing properly, we get 6a plus 2b is actually equal to 0. We divide throughout by 2, we get 3a plus b is 0. This is telling us that b is equal to 3a. very important equation to substitute in here. So we have where there is B. So we now have 25 is equal to 5A, where there is B, we have 3A. This will give us 8A is equal to 25. Oh, not like
Excuse me,
that.
sir.
Yes.
Excuse me, sir. Yes, sir. Is it not supposed to be negative B?
Right. So B is supposed to be negative 3A. So that this
Okay.
we take here now.
Yes.
So that we have 25 is equal to 5A minus 3A. So we get 25 is equal to 2A divided by 2. So A is 25 over 2. So that B is going to be negative 3, 25 over 2, implying that B is equal to negative 75 over 2. This is A and B. Then part B is find the equation of the normal line to the curve at that point 5, 5. So since we already have the gradient of the tangent to be 1 over 4, it means that the gradient of the normal is equal to negative 1 over 1 over 4, which is negative 4. So because this is the case, then we say the equation that we're looking for is the equation y minus ln 5 is equal to negative 4 x minus 5. So we can simplify further. If we so wish, we write it as y is equal to positive ln 5 minus 4x plus 20. So nothing changes in fact. This becomes the normal line. The normal line at the point given.
Excuse me, sir.
Okay.
Maybe I would propose that when you are writing these answers, you probably divide the board in two so that we know where we are starting from and where to continue from.
All right.
This issue of going from right to, I mean, left to right, then back to right, probably when I'm revising, I may not know exactly how we are moving.
Okay, so we do another question. Still on the same. I don't know where my question is. Okay, here. Question 3. Find the equation. Find the equation of the tangent line and normal line to the curve with the indicated conditions. So talk about this condition here. Y is equal to x minus 2 to the power 2 over 3 multiplied by x plus 1 to the power half with gradient 13 over 4. We want this part here. So let me make it a bit light. So I'll put a square here and then I'll leave it like that. Just leave everything like that. Without the square. So y is equal to x minus 2 and x plus 1 with the gradient 13 over 4. So here what you do is you can actually expand this one. Solution. So we got here. So we expand. So say y is equal to x squared plus x minus 2x minus 2, which is equal to x squared minus x minus 2. And then we differentiate this function. We get dy dx, which is going to be 2x minus 1. 2x minus 1. This is called the gradient equation. Now, because of the gradient equation like this, and I'm told that the gradient itself, m, is 13 over 4. It simply implies that 2x minus 1 is equal to 13 over 4. If we take this one the other side, then we'll get 2x is equal to 13 over 4 plus 1 over 1. So that if we put 4 down, then we get 13 plus 16, which is equal to, we get 13 plus 4. plus 4, which is equal to 17 over 4. And then divide by 2. So now what we have is 2x is equal to 17 over 4, implying that if we divide by 2, we get x as 17 over 8. This value of x substituted in the original function, y is going to be 17 over 8 minus 2 and 17 over 8 plus 1. This will give us 8 down for the first one. We'll get 17 minus 16. And for the second one, we'll get 17 plus 8 over 8. So this will give us 17 minus 16, that is 1. And then the other one will get 25. 25 by 1 is to have 25 over 64. So meaning that the point that we deal with is 17 over 8, comma 25 over 64. And the gradient is already given. So we're saying the tangent equation, the tangent line is going to be y minus y1, that is 25 over 64, is equal to the gradient, which is 13 over 4 multiplied by x minus 17 over 8. The second thing, the normal, and the normal line, this is going to be y minus, we now need the same point, 25 over 64 is equal to the gradient. So we'll reciprocate it now, and it will be negative 4 over 13 x minus 17 over 8. Remember, it will always be your duty to simplify here if there is a demand. These are the equations that we are looking for that have their basis on the condition given. Do we have questions?
Excuse me, sir.
Yes.
How did we flip or 13 over 4? Why?
So saying m tangent,
For it to become negative 4 over 13.
okay, so what we have is that the end of the tangent, the end of the normal, the product is negative 1.
Mhm.
So if we have 13 over 4 here,
Okay.
multiplied by m normal is equal to negative 1, it simply implies that m normal is equal to -1 multiplied by 4/50. So I get -4/50.
Oh. Okay, you did